All right, we are back at AP Review. We're doing 2011 Form B, BC Free Response 6. Let f of x equal the natural log of the quantity 1 plus x cubed. Part A, the Maclaurin series for the natural log of 1 plus x is this, which is nice of them to give that to you. Sometimes they make you memorize it. Use this series to write the first 4 non-zero terms and the general term for the Maclaurin series for f. So notice that the difference here is that this guy's an x and this guy's an x cubed. So essentially all I need to do to find the Maclaurin series for f is plug in an x cubed everywhere I see an x. So in part A, my answer is that f of x is going to equal, instead of an x here, I'm going to plug in an x cubed, and instead of an x squared here, it's going to be an x cubed squared, so that'll be an x to the 6th over 2. And instead of an x cubed here, it's an x cubed cubed, which is an x to the 9th over 3, right? And they said the first 4 and the general term. So minus, this is going to be an x to the 12th, because it's cubed to the 4th, right, over 4, plus negative 1 to the n plus 1. It's now going to be x to the 3n, because it's x to the 3rd to the nth power, all over an n, and that's my first bit, right? That's my f of x. Notice that I put the ellipsis at the end to indicate that it's going on forever. Cool. And that's it. That's all I want for A. Part B. The radius of convergence for the Maclaurin series of f is 1. Determine the interval of convergence and show the work that leads to your answer. So they did you a solid here. They don't make you do the ratio test. They just told you, hey, congratulations, the interval of convergence is a 1. You know that it is a Maclaurin series, right? So here's the thing. Since it's a Maclaurin series, that means that the center is at 0, right? And they just told you that the radius is 1. So what that means is you're looking at the window from negative 1 to positive 1 because you're centered at 0 and you're going 1 unit in either direction. So that means that your two ends that you have to check are x equals negative 1 and x equals 1. You're going to check those two ends and see if the series converges or diverges at those two ends. So we're going to check x equals negative 1. When we do that, we're going to get negative 1 to the n plus 1 times a negative 1 to the 3n, which we'll deal with in a sec, all over an n. So this means that we get a negative 1. When we add these, we get to the 4n plus 1, right? So 4n plus 1 is going to end up, when we clean this up, that's going to end up always being an odd number. So, right, because essentially the easy way to think about it is 4n has to be an even number, right? So because 4n is a multiple of 2. So this would have to be an even number, and you add 1 to it, it makes it odd. So what's going to happen is you're going to end up with these all being a negative 1 on top of an n. That's going to diverge because that's the harmonic series, right? It's the harmonic series. Now, it's the harmonic series where everybody's negative, right? It's the harmonic series but negative, but it's a harmonic series where everything is negative, so it diverges. When I do x equals 1, I'm going to get a negative 1 to the n times a n plus 1 times a 1 to the 3n all over n. Well, a 1 to the 3n is just a 1, so I end up getting the alternating harmonic series, right? So this converges because this is the alternating harmonic series. And the alternating harmonic series, so we're going to have a negative, then a positive, then a negative, then a positive. The alternating harmonic series converges, so my answer is that I diverge at negative 1 and I converge at positive 1. So I would write that as parentheses negative 1, comma 1 bracket, or you could write it as negative 1 is less than x is less than or equal to 1. Either of those would be fine. Cool. Part C, right? The first 4 non-zero terms for the Maclaurin series of f prime of t squared. Okay, and then they ask me to do some other stuff. So let's start there. So I'm going to keep my f function because I think I'm going to need it, right? So f prime of t squared, right? So the first thing they asked me to do, and actually let me copy my f up here because I think that's going to be the best thing I can do, right? So minus x to the 6th over 2 plus x to the 9th over 3 minus x to the 12th over 4 plus nth term is negative 1 to the n plus 1 x to the 3n all over an n. Okay, cool. So I'm going to keep that up there so I can use it, all right? So they give you a lot of steps in C. As long as you follow them, you should be fine. So the first thing they ask is the first 4 non-zero terms for the Maclaurin series of f prime of t squared. Before I do f prime of t squared, I should really find f prime of t, right? So, f prime of x rather. So f prime of x is going to be 3x squared minus 6x to the 5th over 2, right? Plus a 9x to the 8th over 3 minus a 12x to the 11th over 4, keep the negative 1 to the x to the n plus 1, but then the 3n's going to drop down, right, over n, x to the 3n minus 1. What I want you to notice is the n's cancel, so I end up getting that f prime of x is a 3x squared minus a 3x to the 5th plus a 3x to the 8th minus a 3x to the 11th. They all end up being 3's, right? So it's a negative 1 to the n plus 1 times a 3 times an x to the 3n minus 1, and that's it, right? So I don't have a fraction anymore. So now I'm asked to find the first 4 terms, not the nth term, of f prime of t squared. Well, that means that f prime of t squared is just going to have a t squared everywhere I saw an x. So even though I wasn't explicitly asked for this formula, I really, really need it. It helps. So now I'm going to get that this is a 3t to the 4th, because it would be t squared squared, minus 3t to the 10th, plus 3t to the 16th, minus 3t to the 22nd, plus dot, dot, dot. Right? And I wasn't asked to find the nth term, so I actually didn't need this, and I don't need that one. Okay, so I was asked to find this, and I did. Then I was asked to find if g of x is the integral from 0 to x of f prime of t squared dt, use the first 2 non-zero terms of the Maclaurin series for g to approximate f of 1. Okay, so g of x is the integral from 0 to x of f prime of t dt, t squared dt. So it's the integral of this thing, right? So I need to integrate those first couple terms, right? And then use the first 2 terms after I've integrated. I'm going to use those first 2 terms. So the trick is that although they didn't actually make me find the nth term for this guy, it's going to be a lot easier if I do. So this guy would have been a negative 1 to the n plus 1 times a 3 times a t to the 6n minus 2, right? Because it'd be 2 times 3n minus 1. So now I need to integrate. Guys, I'm back continuing part C. Sorry for the delay. My computer shut down because it did not have enough hard drive space to accommodate the ridiculous number of videos I've been recording. Oops! So it shut down mid-recording, and so I'm picking up here after a very angry moment when the computer shut down. All right, cool. So where we had left off, right, we had been asked to write the first 4 non-zero terms for f prime of t squared, which I'd done, right? So I'd done that right there, and there's my dot, 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 and then dot, dot, dot. And now we're asked to use that if g of x equals the integral from 0 to x of f prime of t squared dt, use the first 2 non-zero terms of the Maclaurin series for g to approximate g of 1. So what we need to do, right, is we need to, we don't have to write all the terms for g, but we need to write the first 2 terms for g. So g is going to be what happens essentially if I integrate these terms, right? So I'm going to integrate this thing with respect to t and then plug an x in. So if I were to integrate the 3t to the 4th, it would become a 3t to the 5th over 5, right? So what's going to happen is g of x is going to start out with a 3, and I can actually go ahead and, well, I'll put approximate because I'm going to do 2. I could put a 3t to the 5th over 5, but when I plug in x as a bound, it's going to be 3x to the 5th over 5, right? And then the next term, sorry, that's a minus, right? My next term is going to be, I up the 10 to an 11, so it's going to be a negative 3t to the 11th over 11. Oh, sorry, it's not a t, it's an x because I'm plugging in my bounds, right? And notice that when I plug in 0 for the bottom bound, like, it'll be subtracted, but all of the bottom bounds will all be zeros anyway, so it doesn't matter, and they just end up being x's. So I only need those 2 terms. I was then asked to use those 2 terms to approximate g of 1, right? So g of 1 is going to be approximately 3/5 minus 3/11. My guess is that the AP is probably going to want you to clean this up because it's not a completely disgusting thing. Both 5 and 11 are prime, so to get a common denominator, you just need to multiply 3/5 by 11 over 11, which would be 33/55, right? And then to multiply, you'd multiply the 3/11 by a 5 over 5, so you'd get minus a 15 over 55. So you're going to end up getting that this is an 18 over 55. So that's your approximate value. So that was a long prompt, and also, again, I got stopped in the middle by some tech issues. So let's just make sure we did everything in the prompt. in the prompt, we were asked to write the first 4 non-zero terms for this. We do have to find f prime of x on the way there, but we did that. Then we were asked to use the first 2 terms of g, but not write the entirety of g to approximate this, so we should be good. Part D, so I'm going to erase all this stuff. Part D, hopefully we don't need too much of it because I just erased everything. So part D, the Maclaurin series for G, evaluated at x equals 1, is a convergent alternating series with individual terms that decrease in absolute value to 0. Show that your approximation from part C, shouldn't have erased everything, differs from G of 1 by less than 1/5. Okay, so let's just go back to what G was, right? So G of x was approximately, so I'm going to cheat a little because I don't have it in front of me on my board anymore, but I'm going to cheat because I do have it in front of me on another screen. So remember that f prime of t squared, right, was 3t to the 4th minus 3t to the 10th plus 3t to the 16th plus dot dot dot. Right, so when I integrated this, but instead of plugging in, I'm just going to plug in that it's x, so I'm going to integrate this expression, but instead of t's, it'll be x's. We got 3t to the 5th over 5 minus 3t to the 11th over 11, and then the next term, right, would have had a 17, so it'd be plus 3t to the 17th over 17 plus dot dot dot. So if this was what I used to approximate, oh, sorry, they're not t's. Come on, brain. They're all x's, right? If you ever do that on the AP, just fix it, and it can look like that, and it's cool. All right, so this is what I used to do my approximation, right? So, like, this is going to be the thing that I have to max out for my error, right? So, and I want to max it out on the window from 1 until... It's centered, so it's a Maclaurin series from 0 to 1, okay? So I'm going to max this number out from 0 to 1, right? So so G of 1, right, relative to the approximation of G of 1, right, this is a way that we would say error, right, is going to be less than or equal to whatever happens when I max out this term. Well, the only thing I can do is plug in one of the bounds, which is either 0, which is not going to give me a big number, or I can plug in 1. So the biggest this term's possibly going to get is a 3/17, and 3/17 is smaller than 1/5, right? And there's a couple different ways to see that. Like, honestly, it genuinely is smaller. But if you're not able to spot that instantly, one easy way to do that is to just say, okay, cool, well, what would happen if I times this by, there's 2 ways to do it. You can either times by 3 over 3 and say, okay, 3/17 is smaller than 3/15, right? Because it is. 3/17 is smaller than 3/15. The reason I know that is they have the same numerator, right? But a larger denominator means a smaller fraction. So that's an easy way to see it's bigger. The other way to see that it's that this is clearly bigger, this 1/5 is clearly bigger, is you could have just gotten a common denominator of 5 times 17. If that helps you, if you feel better doing that. If you did that, right, you'd get that this is 15/85, right? And that this guy is 17/85, which is clearly larger, right? So either way, and honestly, the AP doesn't need that. The AP really just needs you to say this statement. They understand, so really, their understanding is that you know to use this for error. They're not actually going into great depth that you see that it is actually physically smaller. They understand that you could pretty quickly check in one of a couple ways that that's smaller.